For any right angle triangle, there are trig ratios that help relate the angle to the sides. So for example, if this is our angle, I'm going to call this angle theta, and this is a 90-degree triangle. So a little square here to signify that this angle here is 90 degrees. Now let's also name our sides. This side here is called the adjacent side because it's the side closest or next to the angle. This side over here is called the opposite side. The opposite side because it is directly opposite the angle. And this side here, we always call this the hypotenuse. And it's the longest side of the triangle. So let's take a look at our trig ratios. So the first one is sine, and sine of theta, this is equal to the opposite side divided by the hypotenuse. So that's the ratio of sine theta. Now let's look at cos theta. This is equal to the adjacent side divided by the hypotenuse. And the last one is tan theta. And this is equal to the opposite side divided by the adjacent side. And now one way to remember these ratios is to look at the first letters. Here we have sine is opposite over hypotenuse. So sine is equal to opposite over hypotenuse. And then we have cosine is equal to adjacent over hypotenuse. Cosine is equal to adjacent over hypotenuse. And tan is equal to opposite over adjacent. Tan is equal to opposite over adjacent. And if we put these together, we can say that this is SOHCAHTOA. So here we have sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tan is opposite over adjacent, or SOHCAHTOA. So that's one way to remember that. Let's look at a couple examples now of using this. So, for example, if we have a right angle triangle, I'll draw one here, right angle triangle. Here's a right angle triangle here. And let's suppose that this angle here is 35 degrees. Now we need one other piece of information in this triangle in order to solve for the triangle and get the other sides. So if we have, for example, if we're told that this side, the hypotenuse, is 12, now we can use these ratios to find the length of the other sides. We can already get this angle, as we know that the sum of the angles in a triangle is 180. So the sum of the angles in a triangle equals 180 degrees. So we already have 90 degrees and we have 35 degrees, and we just need one more, this one here, in order to get 180 degrees. And so we could solve for this, and that would be 55. So x is equal to 55 degrees, and that's this angle here is 55 degrees. Okay, let's use our ratios to find these two sides. So I'm going to call this side the opposite side and this side the adjacent side. It's adjacent to this angle here that we've been given. So now we can use either the sine or the cosine to get these two angles. So let's start with using sine. So we have sine of 35 degrees, and this is equal to our opposite side over our hypotenuse, which is 12. Now if we multiply both sides by 12, then we get 12 times the sine of 35 degrees is equal to our opposite side. So if we go ahead and do that, we should get that that side is equal to, the opposite side is equal to 6.88. Now let's do cosine to find this adjacent side. So now we have the cosine of 35 degrees is equal to the adjacent side over the hypotenuse, which is 12. So 12 times cos of 35 degrees. And if we multiply this out, then we should get 9.83 for our adjacent side. So this side is equal to 9.83, and this side was equal to 6.88. And now we've solved for this triangle. We found all the missing sides.